All right, let's talk about the Twinkle artifact. All right, let's look at this color cine loop. It happens to be of the kidney. And the first thing that will strike you is that there are a lot of vertical, light blue, yellow, orange signals coming from inside the kidney. And that's not typical of what we see in a normal vascular structure. And it's called the Twinkle artifact. To explain why we have the Twinkle effect, we need to back up a little bit and talk about the normal kidney versus our kidney over here that is diseased. So on a normal kidney here on the left side of the image, it should be hypoechoic predominantly, surrounded by a hyperechoic ring. On the internal part of the kidney, in the very center, it should be very hyperechoic. That's the collecting system that's collapsed. And these very anechoic fingerprint type areas, those are the renal pyramids. So that's a normal looking kidney. And on this kidney over here, it has medullary nephrocalcinosis, and that's a buildup of calcium deposits within the medullary part of the kidney. And we remember that calcium is a strong reflector. Now, these are not stones, it's just deposits within the medullary part of the kidney. And because it's a strong reflector and it is calcium, we do see these areas of posterior shadowing as the sound beam's going through and sending most of itself back. So those areas right there are, if you'll remember, where we see these vertical, very blue, yellow, green areas in the Twinkle artifact. So why does the ultrasound machine register the posterior shadowing and the interaction of the sound beam with these calcium deposits as a Twinkle artifact? Why does it appear to be movement when it's actually not? What happens when the ultrasound machine uses color Doppler? It's analyzing the frequency shift. That's what Doppler is. It's just a frequency shift that it's analyzing. In that analysis process within the ultrasound machine itself, it creates noise, which we don't usually see or hear, but the machine is creating that heat and noise. And when just during that color Doppler, when the noise is generated and the noise interacts with the strong reflector of the calcium, it causes this Twinkle artifact. It causes the machine to take that interaction and register it as color. When it actually isn't, it's just an artifact of a strong reflector with the intrinsic noise of the color Doppler processing. So that's why we get that. But it ends up being very helpful to us, particularly in the kidney. Sometimes kidney stones or this calcium deposits throughout the kidney can be difficult to see just on grayscale. And you might think there might be stones deposited in or calcifications. And if you turn color Doppler on, you're using the Twinkle artifact to be able to identify that there is indeed either calcium or small stones that were hard to see. So now if we look at the cine loop again, it's very clear what's Twinkle artifact and what is actual renal flow. We can see right over here, here's a still at the very end of the cine loop, where you can see this is definitely color Doppler vascular flow. It's red, it's blue, and there's no stenosis here, so there's no turbulence within the vessels. And right over here is just a little bit of the calcium and noise interaction causing that Twinkle artifact. It's all light blue and orange and red, which would normally be interpreted as turbulence from stenosis, which can happen in the kidney vasculature. It's one of the common reasons for hypertension. So being able to distinguish what's color flow, normal color flow, and what's Twinkle artifact and what might be causing it is is a very important interpretive skill, an eye training skill, and very, very useful within the kidney itself. Hopefully that's been a helpful explanation of the Twinkle artifact.